Today's lesson is on completing the square. Recall that when we talked about the quadratic relation, we said that the quadratic could be written in three different ways. We could have the vertex form, the standard form, and the factored form, and each of the ways have a purpose. Now, going from vertex to standard form, similar to going from factored to standard form, in both cases, we would need to expand. When we're going from standard form to factored form, we would have to factor, and going from standard form back to vertex form, we have two methods. The first method we talked about was using the equation h is equal to negative b over 2a. A second method that we can use is called completing the square. And this is what we're talking about today. Do you remember these perfect square binomials? When we expand it, we always come out with this pattern where our trinomial, or a perfect square trinomial, ends up having an a squared, middle term being created by 2 times a times b, and the third term being created by b squared. All of these, the a and b, come from the original binomial. I'm going to do this using both methods. Method 1, I'm going to expand x plus 5 times x plus 5. We have x squared plus 5x plus 5x plus 25. Collect the like terms, x squared plus 10x plus 25. Method 2, we're going to use the shortcut equation to get to our final answer. So the first term is created by a squared. In this case, a is our x, so I have x squared. The second term is created by 2 times a times b. So 2 times x times 5, that gives me 10x. And the last term is created by b squared, 25. We have the same answer, we've just done it two different ways. Let's use the shortcut to help us find the answer to this one. When I expand, I'm going to have a squared. A term here is 2x, so 2x all squared is 4x squared. Second, we're going to have 2 times a times b. So I have 2 times 2x times 3y, 12xy. The third term is created by the original b squared. So 3y all squared, 9y squared. Let's examine this a little more closely. The coefficient b and c are related because the b term is 2xy and the c term in the trinomial is a y squared. So if we're ever given just a part of the equation and we know that this is a perfect trinomial, we're able to find out what it is because we know this pattern. So the first question, 2x squared plus 10x plus question mark. Now I know that this is created by 2xy, and that's 10x. I could rearrange this and use algebra to find out what my y term is. So I have y is equal to 10x divided by 2x. Y is equal to 5. Now, as a result, I know that my last term has to be y squared based on my original equation. So in this case, y squared is equal to 5 squared or 25. So the equation here, my c term, is going to be 25. Let's do the same thing for the second one. X squared minus 24x plus some number. We know that the middle term was created by 2xy. Negative 2xy, and we have negative 24x. So what is y? Let's rearrange it. We have y is equal to negative 24x divided by 2x. Y is equal to 12. My last term must be y squared. So in this case, I have y is 12, and 12 squared is 144. So we get my unknown value is going to be 144. Now we can always check these by factoring to see if it comes back to a perfect square binomial. So in summary, what we've talked about is we've used this equation to create a c term that would make a perfect trinomial. We take the middle term, divide it by 2, and then square it. So let's find a c term that will make this a perfect trinomial. We know that c is created by b divided by 2 and squared. So in this case, we have negative 8 divided by 2, and it's squared, so we have c is equal to 16. The equation we have, y is equal to x squared minus 8x plus 16. And as a perfect binomial, we would have x minus 4 all squared. Now, sometimes we have an equation that starts with a coefficient for the a term. What we're going to do is we need to first factor the a, and then we're going to develop the trinomial that is perfect. So in this case, we have y is equal to 3 bracket x squared minus 12x, or sorry, 4x. Now we're going to take the b term, divide it by 2, and square it. So we have 2 squared is 4, and this is a perfect trinomial. Now as the factored form, we have x minus 2, and the bracket is all squared. When we're going from standard form back to vertex form using the completing the square equation, we're first going to factor out the a, then we're going to introduce a new c term so that we get a perfect square binomial. Now, if we have something remaining, actually, and since we're introducing this, we have to remove it at the end. We have to leave no trace. Kind of like if you're going camping, you go into the forest and you're supposed to leave no trace when you leave the campsite. You're not going to be leaving garbage. You're going to be taking everything back with you to throw out in the appropriate places. Then you're going to factor the perfect square trinomial, collect your like terms, and then you'll write it in vertex form. So this might be a little confusing at first. Let's do an example to try to make this a little more clear. So for us to write this in vertex form, we need to first introduce a C term that would create a perfect square trinomial. X squared plus 14x plus, and our C term, 14 divided by 2, that is 7. 7 squared is 49. Now we're going to leave no trace, so we're going to take away the 49 as well, because the 49 was introduced and it wasn't part of the original equation. The original equation, though, had a -1, so I'm rewriting the -1. Right? Let's just mention where these came from. So the 49 was created by e divided by 2 squared. This extra 49 was created by the leave no trace. The -1 was part of the original equation. Now, let's factor the first 3 terms here because that is part of a perfect square trinomial. We have y is equal to x plus 7 all squared. Now we're going to collect the like terms for what we have left, and that's the last 2 terms, minus 50. Where did we get that? The first part was factoring the perfect trinomial. And the perfect trinomial that we had was x squared plus 14x plus 49. This -50, we collected the like terms of -49 minus 1. And now we have this in vertex form. Let's do another example. How to go from standard form to vertex form. Now, since we have an a here, we need to remove the a from the first 2 terms before we can continue. So we have y is equal to 2 bracket x squared plus 12x minus 3. I've just factored out the 2 from the first 2 terms because we know that the first 2 terms will be what comprises the perfect square trinomial. Next, I'm going to introduce our c term. So I have x squared plus 12x. Take the middle term, divide it by 2, and square it. 12 divided by 2 is 6. 6 squared is 36. Now we have to leave no trace, so I'm going to subtract 36 as well, and then I'm rewriting the -3. Okay, so this first 36, it came from e over 2 squared, and then our -36 was leave no trace. Let's factor the first 3 terms in our bracket because that's our perfect square trinomial. I'm going to put this in square brackets now because it's only this first part that I'm concerned about. X plus 6 all squared. I'm rewriting minus 36 and I'm rewriting the -3. The reason I'm doing this is because I can't collect my like terms of just these 2. The negative 36 is inside the bracket. So if I wanted to expand it and collect the like terms, I need to take the 2 and expand. So we have y is equal to 2 times x plus 6 squared minus 2 times 36 minus 3. So the 2, I've expanded the square bracket. So now that we've expanded the square bracket, we're going to collect the like terms. X plus 6 squared minus 72 minus 3. And finally, we have y is equal to 2x plus 6 squared minus 75. Okay, let's do this again. We're going to complete the square and we're going to graph it. So we're not going to graph using a table of values. Instead, we're going to use our vertex, and then we're going to use the knowledge of what a normal parabola is and plot the rest of the points. So since my a is a -1, I'm going to first factor out my -1 from the first two terms. Next, I'm introducing a c term by taking b, dividing it by 2, and squaring it, and I'm going to subtract it as well. Next, I'm going to factor the first three terms. So I have x plus 3 all squared minus 9 minus 5. Let's expand by taking the -1 and distributing it to everything inside the bracket. Negative x plus 3 squared plus 9 minus 5. Y is equal to negative x plus 3 squared plus 4. Now we are in the vertex form. We know the vertex is -3 and +4. -3, +4. We know that there is no stretch because this is a -1. The only thing is that this is a parabola that opens down. And so we have a parabola that looks a bit like this. I'm going to connect the dots. That's not a very good one. And we have a parabola that looks a bit like this. Okay, now sometimes we have a fraction that's created. We're able to deal with that because we know how to work with fractions. Okay, so let's rewrite this. X squared plus 5x. Our middle term is going to be 5 divided by 2 all squared. I've introduced that. Now I have to take it away and rewrite the rest of the equation. Let's factor. Since this is our squared term, we know what the y is. So we have x plus 5 over 2 all squared minus 25 over 4 plus 7. Let's continue to simplify by collecting the like terms. 25 over 4 plus 28 over 4. x plus 5 over 2, and now dealing with our fractions, we have 3 over 4. We've rewritten it, we know what the vertex is, but we had to deal with it in fractions. If you're unsure how I got all of the fractions, you might want to review it or figure out how to do fractions using your calculator. All right, and that is it for the lesson.